Great. Well, hello, everyone. Welcome to another Matchbox workshop where we bring on a guest to talk about their project related to StarkNet's ecosystem and specifically, on-chain gaming. And if you're not familiar with what Matchbox is, which I'm sure most of you are, we're an ecosystem of developers and designers and writers, educators, just all sorts of participants. And our goal is to bring on-chain gaming to the next level, specifically on StarkNet. So this means building the infrastructure, the actual games and tools that we'll be using and playing. We also mentor developers, and that's in the form of, just advice from our more senior developers that are also building out primitives and offering grants to, other developers that have ideas that we think could be useful to the ecosystem. And we also think it's just as important to educate people who are already in the community and people that are interested in joining the community about, all the useful tools and games that we think, could foster an interesting place for people to have fun. So today we're having Francesco, who is, let me admit all these people. Hold on, give me one sec. Did they join? Not sure if they joined. Anyway, yep. Okay, they're joined. Hi everyone for just joining. All this stuff is going to be recorded, so if you've missed anything, you could just refer to the recording after the meeting. But yes, this is Francesco. Francesco is working on an NFT marketplace protocol. And he's also developed a React library on StarkNet, which will be really useful because I think that if any of these applications, or if I guess layer 2 is going to go, more mainstream, then, UX is really important. And so he'll be here to talk about his React library, which, if you are familiar, Salt Mint actually used it. And Salt Mint's the new game that Matchbox just pushed with Guilty Gyoza, which is really cool, and seeing some participation. So if you haven't checked that out yet, please do. I'm sure you'll find information in the Discord. And so without further ado, this is Francesco with his React library. Take it away, Francesco. And if you have any questions, feel free to ask them or leave them in the comments. We'll also open up at the end for general questions.
Okay, so thank you for having me today. And let me share my screen. I have a presentation. Okay, so again, today is a workshop about StartNet React, which is a library to build interfaces for web browsers, like a web application for to connect with StartNet. I just want to say thank you to the StartNet.js team, because basically the React library is just a theme wrapper on top of the StartNet.js library, and they do all the heavy lifting, for interacting with StartNet. And just all the StartNet React library does is that it makes it very easy and very convenient to use it from inside a React application. And also the source code is available on GitHub, and you will see this address again at the end. So, and here is the repo. So you can find basically the source code that we are going to look at today. And so what is StartNet React? So the idea is that StartNet React is just a collection of hooks for React to use so it's a collection of hooks for StartNet to use in React. And so how do you get started with that? So usually setting up a React application is not trivial. It's just very annoying. There's a lot of little moving parts to manage. And so I create a template for basically a StartNet React application, and that's the commands you can run. And in the README of the project, which is again on GitHub, you can just copy and paste the command and run it from your application, from your command line, and you get that template to get started. And also I have to warn you, if you use a create React app, your application will not work. And you will get like an error, you will get a blank page, and it's a known issue. It's an issue with StartNet.js, not with our library. So just use Next.js for now. Just easier. Okay, so the first thing to know is that basically we need to wrap our application in what is called like a StarkNet provider. And why is that? Basically, the idea is that all the global states that we need to keep track to connect with StartNet is basically shared across all the subcomponents without having to pass them as props. And so that is something that we have to do for every application. And so now we're going to see here we have like the code from our repository, and it's just a standard Next.js application. You can see that we are changing the file, the app.typescript file, right, which is the one that basically wraps the page when it gets rendered. And I'm using for the UI, I'm using Chakra. And so I wrap the application in the Chakra provider. And then I want to use StartNet, so I wrap my application in the StartNet provider. And you can see it's important from the StartNet React code. And then here we render the sub components. And that means that every component here, so the page that gets rendered and, for example, the network status widget that we're going to see later, they have access to the StartNet state. And just to see what we are going to build today is just this very simple application. On the top right corner, we have like the classic button where you have your account and the list of recent transactions. Here we show the user balance for the test token, the one that you also get in Argent. Okay. And Argent, oh yeah, there you can see it. So that's the test token. And then we can basically interact with the test token to transfer it to another account. And finally, in the bottom right corner, we have this network indicator, which now is green, means that we are connected. And that's the latest block produced by StartNet. If I refresh the page, you see the state is loading. So it means it's loading a block. And after it finished loading the block from StartNet, it switched screen and it showed the current block number. So that's what we are going to build today. Okay, so what are we going to build first? Well, so first of all, that's the whole hooks that the library includes, that the library provides. And we are going to use each one of them today because they're all very useful when building an application. So the first hook is the use StartNet block. All it does is just returns the current block number, which the block data from StartNet, and it automatically fetches new data. So we always have the freshest block. And you can use this one to either trigger some other computation at when our block number changes, or in this case we just show it to show if you are connected to a network or not. So let's see how to build that widget. So so everyone is on the same page, we are going to build this small thing on the bottom right corner. Hope you can see it. Should have made it bigger. And so it's what I call network status. And so here you have everything, right? So it's just a normal component, a normal React component. And here we use our hook, and it just use StartNet block, and we get some data which we contain the block response, then a flag that returns true, that is true when we are loading data from the chain, and false when it's not loading. And basically error in case we are not connected to the network or there's any type of issue. For example, recently we have seen that the StartNet gateway sometimes returns errors. And so if basically the widget cannot get data from the network, that variable will be set to error. And so here we load the data, and we use this memo hook. What it does is that it basically sort of caches the value returned by this function. And so these values are recomputed every time either data or error changes. So at the beginning, data and error will be undefined. And so this function will return the value of blue, which is the color that we will use for the indicator, so for the dot. And then the next hook, we use the similar pattern where we return either the block number or just some text that we want to display. And again, this data is automatically refreshed every time something changes. So either the block number changes or the network status changes. And finally, we just render this data. So we use the text that we return from the second hook inside the text, and then we change the color of the indicator based on our status. And then when we look at it, now it's green. I refresh the page, it's blue. And now the network is back to being a bit slow, so it will take a while before it becomes green. And maybe we will see it becomes red if there's error. But no, it was green, and that's all, right? So we didn't have to do any of the polling ourselves. We didn't do. If you look at the code, we don't have any real logic about our network status, right? We don't have any logic that deals with fetching data from the chain. It sort of like automatically refreshes the data, and we automatically recompute the values that need recomputing. So it makes it very easy to work with this type of data, which would be very annoying. And so now to the next thing. So the other hook that we use basically every single time is the use StarkNet hook, which tracks the current basically wallet connection status, if I can say that, and basically returns the currently connected account, if any, and then also it provides us a function to connect with what we call like a connector. For now, there's only the injector connector, which is basically agent apps. And we are going to see soon how to use it. And the next thing we are going to see how to use soon is this transaction manager. So every time the user sends a transaction to StarkNet, we want to start tracking this transaction so that we can show it. So like usually in the upper right corner, we want to show users a list of recent transactions they sent. And this library makes it very easy because every time you interact with a smart contract, and we will see that later, it automatically tracks the transactions, and you can just get the list of transactions from this hook. And so now we are going to look how to build this widget here, where it basically says connect wallet. If you are not connected, then I click, and it connects to my wallet. And I see I have no transactions here. And yeah, it's here. Okay, so we have this connect wallet component that uses this hook that we provide, I mentioned earlier, the use StarkNet, to get both the currently connected account and a method to connect to a new account. And then here it uses like basically gets a list of all the user transactions. So if the user is connected, so after I click connect wallet, the value of account will be not undefined, and so we will basically render this part of the component. Basically, we just display a simple menu. We show like a human readable version of the address. So we don't display all 32 characters, but only the first and the last characters. And then here we go through each transaction, and we just show the transaction hash. In a real application, here we would probably show also like a link to say Voyager, so that user can inspect transactions and they can store it for later. But since it's a demo, we just keep it easy and simple. And then here, if the user was not connected, we just show a button that asks the user to connect the wallet. And when the user connects the wallet, here we can see that basically we call the connect method, and we pass the connector. In this case, the only available wallet for StarkNet is ArgentX. And so we just pass the injected connector. We build a new instance of it and pass it. In the future, when there will be multiple wallets, for example, wallet connect, we will have different type of connector. And depending on which button the user clicks, we want to connect to either the injector connector or wallet connect or other applications. And so that's how I think here you can see why this type of library is very powerful, because in basically 30 lines of code, we have a working, maybe a bit ugly, but it's a working like connect wallet button that shows a list of recent transactions. And again, as a developer, you don't have to do any of the difficult things like keeping track of transactions or connecting with different type of wallets, because we do everything for you. And now finally, we can see the meaty parts, right? So how do we interact with a contract? And so that's basically we define two things. One is that this hook is used to basically build a contract object. And again, this contract object is from StartNet.js. And all it does is that it automatically rebuilds the contract class when the API, either the API or the address changes. So in the future, when we have multiple versions of the network, we can, for example, change the address depending on the currently connected network. And this hook will recompute the contract for that new address. And so again, you don't need to manage these type of things yourself. And then finally, we have the first what I would call like a heavy hook, in that it does a lot of work, which is the use StartNet call hook. And this hook is used to make a call to the contract. And eventually we pass we call a contract. We need to pass the contract, then the method, and the method is the method name, and then the arguments with which we want to call the contract. And one thing to notice is that this hook is implemented so that every time the block changes, that it makes a new call. So we always have fresh data. So for example, if a user sent a transaction, when the transaction is confirmed, there's a new block, then the balance will be automatically refreshed. And I guess so that way we don't need to, as application developers, we don't need to keep track of all these low-level details. Like, if the user sent a transaction, do we need to wait for a new block to refresh this value or not? That type of things really makes developing applications slower and more annoying. And these hooks make it very easy. So let's go here. And the first hook is this use token hook, right? So the idea is that we want to return to have a hook that we can call so that we can automatically get the instance of the contract connected with our token. So in this case, we just simply wrap the use contract hook provided by StartNet React, and we pass the ABI, which I got from the Argentex repository, and the contract address, which again got from the Argentex repository. And now we can implement it. Look at the token view. So the token view is this area here where we display the user balance, and then we have a small area where they can input the recipient and the amount of money they want to transfer, and then they can transfer it. And here, basically, we decide if the user has their account connected or not. If they're not connected, right, we just ask them to connect their wallet. Doesn't make sense to display their balance because they have none. So we connect, and now if we are connected, you can see that it's loading the balance. And yeah, probably the network is being slow right now, so it will take a while. So you can see we have two sub-components, one basically where we display the token balance, and the other where we interact with the wallet. And so here we see that I call the hook that I showed previously, that I call like use token contract. All it does is basically returns a contract instance already connected to the right account. I mean, with the right address on chain. And then here we make our first call. And we see this method returns again data, loading, and error. Data is an array of values that are returned by this call. Loading is a flag that is true when we are fetching data from chain. And error, if there's any error fetching data, we will return like some values so that we can display to the users. And here we basically calling the balance of method from the ERC20 standard. Now, I think this line is very interesting. Because you can see that I'm asking, is account undefined or not? And if the account is defined, then I pass basically I set args to an array with only element the account. Otherwise, I set it to undefined, right? Why would I do that? Why would I not pass like an array with the first element that is undefined when an account is undefined? So the way this hook is implemented is that if the argument is undefined, then it will not make any call, right? So that we know that the call will fail because we need to pass a valid account to ask the balance of, right? And so that way we can sort of like force the library not to make any call until we have an account. And we do that by setting the arguments to undefined if account is also undefined. And I think that's one of the most important things to know about this hook is basically if you know that the code will fail, don't make the call, right? Otherwise, the value of error will be to something that's sort of like defined, and then you will display an error message, even though it doesn't make sense to display an error message in that case. Okay, so now we made a call, and the library will automatically make a call at some point. Yeah, for example, now we see that here it made a call, and now we have the zero balance. And so the value of data will go from undefined to something, to basically an array of values. And here we pass the value to something that we like. And so StartNet.js provides this convenience function that converts like a signed integer from the chiral representation, so as basically a structure of low and high bits, to a bit number. And so we use this function to pass the values to a bit number from this struct, and then we just convert it to string because we want to display it to users. Now here, basically, we say we can start displaying data to the user. Here we said that if the balance is not undefined, so this part here is a bit early, it just to avoid, because sometimes it's a value of 0, it's also considered false, so you will display something wrong. And then if a user has balance, we fetch it, then we just display their balance. If it's a token that they don't have any token, then we will just display 0. Then, as we've seen earlier, when we basically start making the call, so after all arguments are not undefined, we make a call, and the value of loading will be true because we are loading data from the chain. And so we want to sort of show, like in this case, a text message to the user to say, oh, we are loading the balance from the chain. And then if there was any error, we just want to display it to the user. There was an error. Usually it's a network error, so they know that there's an issue with the chain, not with your application. And that, again, you can see that basically in 20 lines of code, we have a component that can display the balance, and it's quite smart because every time there's a new block, we fetch new data. And if there's any error, like you get the value and you just show it to the users, and you can even like show a loader or any like type of sort of like indicator so that the user knows that your application is not frozen, it's still like live, and it's still fetching data every now and then. And so that's this component here. And now we are going to the last component, to the last hook, which is the StarkNet Invoke. This hook is used to basically call like an external function on your Cairo contract. And in this case, unlike the StarkNet code, you only accept two arguments. One is the contract, again, and the method name that we want to invoke. It cannot accept arguments because basically it doesn't know when it should make the call. And so it returns the data. Actually, let's see the example and let's see what it does here. Right, so yeah, here, and now here we keep track of some state that we see later, and that's how we use this hook. Basically, we just, we say we want to call the transfer method on this contract that is our token contract. And this hook will return a few values. One is the loading, basically, that is a value that's set to true when we are sending a transaction. For example, even I think when waiting for confirmation from users. Then an error value that is set to something not undefined when something goes wrong. So for example, the user declined the transaction or something like that. And then we have two methods. One is to actually make the call to the contract, and the other is to reset the state. So we want to clear the state. Maybe we are showing like a error message to the user. We want a button to sort of like delete the error message. We can just call this reset method, so all the state is sort of like reset to before we made the call. And let's see how this component should work. So I need to input the address of an account, which in this case is my other Argent account. Let me switch back to the original account. And then I send an amount, 1, 2, 3, click transfer. Now there's network fee. And you see I disable the button because I'm checking for the loading flag. And now my application knows that I'm still waiting for the user to confirm the transaction. So after that, click sign, and now it's sending a transaction, and it's sending. It will take a while, and now I'm ready. I could send another transfer if I wanted. And what's cool is that this transaction is automatically tracked by my wallet, by StartNet React, so that we can show here a list of recent transactions. And this icon shows that the transaction has been received by the StartNet gateway, but has not been accepted yet. And what this StartNet React library does is that in the background, it will keep refreshing the data every, I think, 15 to 20 seconds with every block, or I think every block. And so that it always knows the status of a transaction. And again, that way you don't need to manually track the transaction yourself. And also, like when you're building like a big application, sharing state between a component that's here and is very deep in the component hierarchy, and this area here, which is a completely different area of your hierarchy, is tricky and is very annoying, and this hook does it for you. And so if I now transfer another amount of money, you will see that the transaction will show up there as well. And now we have two transactions here, and we will see what one of them will be accepted before the other, probably, because we sent it a bit earlier. Anyway, we have to wait for that. Okay, so let's see how it works. So as you see, we need to track basically two things. One is the recipient, and the other is the amount. But because the amount has to be a number, we also want to sort of like do some parsing, because we know that if a user inputs a number that's not really a field element, it will fail. So we also want to display an error message to the user. And I haven't shown that, but if I put something that's not a number, it shows an error message. Probably like for a real application, you want to use like the form hooks library, or any like Formit, or any of these libraries that make it very easy to implement forms with validation in React. But for a demo, I think that's more than enough. Okay, so that's our component here. We basically have a feed for the recipient, and every time it's a normal text feed, and if anytime the recipient changes, we update the value using the state hook. And then we have a number feed, and this case we need to first pass the amount to check if it's a valid number or not, and then update the value. And if there's any error in the amount, we display the error message that I've shown. And then we have a button that is used basically to transfer the amount, and then close like this pullback that later we will look at. We disable the button when we are sending a transaction, so when the loading flag is set to true. And finally, we display an error message. So I haven't showed that. So for example, when I click I reject, then I know that the user aborted the transaction, and so basically I should, I cannot send the transaction because of that. And so I can show error message to the user to warn that they just, they were trying to send money and then decided not to do it. And here, this first callback simply passes, basically set the amount to the new value, and then, because, any case, and then it tries to convert the value to a bit number. If that's not possible, it means that there was an error, and so the user should input what is a real number. And then here is simply the function to invoke the contract method. So first we reset the state, so we have a fresh state. Then we check that it actually makes sense. So is the user connected? Is the amount they input correct? And is there like a valid recipient of the amount? And now we use the other function provided by StartNet.js to convert from a bit number to our unsigned integer. And so we use the call so that we have it. And finally, we can invoke the method or the contract. and we pass as arguments the recipient and the amount. The order of the two arguments depends on the ABI, so check for that. And that's all we have to do to send a transaction. It's really like basically a couple of lines of code. And now, obviously, there's no way it was accepted. Basically, when the transaction will be accepted, the value here will be updated, and it will display like a nice check mark because the transaction was sent, and the balances will be updated automatically. So again, they succeeded. Now let's see. You see, there's a nice check mark, and the balance will update soon. Oh, and now we see the balance here was updated. Again, if you notice, there's no part in our code where we need to keep track of state. And I think building front-end application, the difficult thing is keeping track of state. And this library basically does everything for you. And so that's all. Basically, you can find the library on GitHub. You can find the workshop files on GitHub. And it's the same I showed you today. And then if you have any questions about the library or anything StartNet, you can ask me on Twitter.
Sweet. Sweet. Does anyone have any questions for Francesco while he's here? Like you said, all the info is here. We've recorded it, and you can find them on Twitter. That's super useful. Okay, well, if no one has any questions, thanks for coming. We hope that as you guys dive through the library, if anything comes up, feel free to drop a note in the Discord, or how to reach Francesco now. So thank you guys, and stay tuned for the next one. I think the next workshop is going to be really interesting, and there'll be an update, I think, in the next couple of days about that. All right, thanks, Francesco.
Thank you.
All right, bye.
Thank you.
Yep.